everyone, and welcome to another lesson from Redwood Academy. Today, our grade 12 maths topic is functions, and the subtopic is inverse functions. All right, so just to talk a little bit about what's going on. Remember, we are in isolation because of the coronavirus, COVID-19. Initially, if you remember, there was one infection, two infections, and people were kind of not too worried, right? Overseas, internationally, they were telling us, no, you have to worry. And then we saw 5 and 7, and then it started increasing quite a bit, right? Everybody was shocked when they said over 100, 400, and now sitting on about 1400 and something, right? So we call this exponential growth. Okay, and if you had to represent this on a graph, it would look something like you learned in grade 10 and 11 exponential functions. It would look something like that, right? So just think about these things because, you know, when we do pure math, sometimes we just do because we know or we learn, right? But especially with current affairs, there's a lot of statistics, a lot of data flying around, and you can really take advantage of that and put your maths knowledge into use there and understand things much better. Okay, so let's move on now to the actual work for today. So we're looking at inverses of one-to-one linear functions. All right, so a linear function, remember, is a straight line. Okay, I'm just going to draw one here. All right, so that's my y-axis, that's my x-axis, and I'm going to draw something like that. Okay, all right, so that more or less is a straight line graph. Now, when we talk of inverse, right, we talk of folding over the line y equal to x. All right, now you see I've got a dotted line here. This is my line y equal to x. The line y equal to x is always a line that cuts the x-axis and the y-axis into two exact halves. In other words, it bisects it, right? Now, when we fold over this line, then we get what we call the inverse function. So if I take the piece on top of the line and I just simply fold it over the line, I'm going to get something like that. Okay, and then if I take the bottom piece and I fold it over the red line, the bottom piece is going to come over to the top. So it's more or less going to look something like that. Okay, now when we refer to an inverse, if I had called this graph f, I would call this graph f inverse. Right, so f to the power minus 1. All right, and generally, if you look at what's going on here, right, this is a line y equal to x. Okay, and if I fold over this line, it means that I've switched or swapped x and y. Right, so in other words, where there was y, I now have an x. Where there was an x, I now have a y. All right, and that's the principle that we're going to use. So we're starting off very simply here. In the textbook, exercise 2 says, consider the following function f of x equal to 2x plus 4. All right, so the question says, for each function, determine f minus 1. So f minus 1, that is always inverse, right? Remember, it is not f with an apostrophe. Later in the year, you'll learn that in calculus, this specifically is f minus 1. And they want us to find this in the form f minus 1 of x equals 2. Right? Now remember, that is an equivalent of y equal to form, but this is inverses we're talking about. Now, last year you guys did learn the rule to find an inverse is to swap your x and y values. Right? So that's a very, very important rule that we are learning here. Remember, f of x, right? F of x is y, okay, equal to 2x plus 4. And if I have to swap x and y, then instead of y, I put x, and instead of x, I put y. All right. And generally, you always need to get your graphs into y form. Right? Remember, for straight lines, it will be y equal to mx plus c. So I'm going to take my 2y over. That's going to become minus 2y. Right? I'm going to take my plus x over. It's going to become minus x plus 4. And then I'm going to divide throughout by minus 2. And I'm going to get minus 1 divided by minus 2, which is a half x, and then plus 4 divided by minus 2, which is minus 2. Right? And that is the graph of the inverse. Now, just put it in the form that they did ask for. So they asked for f minus 1 at x equal to a half x minus 2. Right? And that is exactly what they asked for. So that's how you determine the inverse. Remember this very, very special rule, swap the x and y values. Okay, let's go on to the next one. All right, so the next one says, hence draw a neat sketch graph, or hence draw neat sketch graphs of both functions on the same set of x's. So obviously, you guys from grade 8, 9, you've been learning how to sketch graphs. Okay, so to sketch this graph here, they're saying, firstly, f of x, the original graph, which was 2x plus 4, I simply let x equal to 0. So I'm going to have y equal to 2 times 0 plus 4, and that gives me y equal to 4. Right, let's go and plot this. Right, so we've got y equal to 4. That's 1, 2, 3, 4. That's y equal to 4. All right, then let y equal to 0. So if I take the same function and I let y equal to 0, I'm going to get something like this. 0 equals to 2x plus 4. Take the 2 over, minus 2x is equal to 4, and then divide by minus 2. Therefore, x is equal to minus 2. All right, and then I get minus 1 minus 2. So I get something like that. Well, that's minus 2. All right, and they want me to draw a graph of that, right? So I'm going to get my line. Right? I normally don't draw very straight lines, so I'm going to use this on the smartboard. Okay, and I'm going to draw a line. Right? So it's something like that. Should be 100%. Okay, so that's my line. Okay, so that is the graph of f, right? Let's label that as the graph of f. All right, then the inverse, right? So the inverse, remember now from the previous question, we found the inverse to be half x minus 2, right? So y equal to a half x minus 2. Okay, so I'm going to let x equal to 0. Therefore, y is equal to a half into 0 minus 2, right? And that gives us an answer of minus 2. All right, which means y is equal to minus 2. All right, so minus 1 minus 2, y is equal to minus 2 is somewhere there. Okay, then let y equal to 0. So if I let y equal to 0, I'm going to get 0 equal to a half x minus 2. All right, and from there, I just got to solve, right? So I'm going to take the 2 over, and I'm going to have a half x equal to 2. And if I times both sides by 2, I'm going to get x equal to 4. All right, so let's go to 1, 2, 3, 1, 2, 3, 4. That's x equal to 4. All right, and I draw that line. Okay, so let's get the line. So maybe give it a different color. Okay, and then we've got to draw this line here, okay, which is more or less something like that. Okay, let's just give it some arrows. All right, and there is the graph of f inverse, right? So f inverse, and there you go. All right, so that should be pretty simple. You guys have all drawn lots of straight line graphs in the past. And yeah, you see that's how it goes. All right, so the next question then says, draw the line of symmetry on the same set of x's as the two graphs. Now, what does symmetry mean? Symmetry means cut in two exact halves, right? So divide equally. All right, now you guys have seen at the beginning of this lesson that we looked at that line y equal to x, and we said when we find the inverse, we are folding over the line y equal to x. Okay, so if I go here, the symmetry line basically has to be that line y equal to x. Okay, so it's a line y equal to x. Okay, let me get a line here. Let's get a dotted line. Okay, let's give it a nice color. And we're going to draw that in here. Okay, so it's something like that there. Now, you see that that line then runs through my origin. Okay, and it is the line y equal to x, right? And it is cutting my graphs into two exact halves, right? So on either side, you'll see exactly the same thing. Okay. All right, and then the last question of this set says, determine the coordinates of the point of intersection of both graphs and then indicate the point on the diagram. Now, remember point of intersection, right? We did do this a lot in the past, okay, is a simple rule. You solve simultaneously, or in graphs, we like to just say equate the graphs. Right, equate the graphs, right? You guys must make a note of all of these rules, right? Because they come out so often and it's such easy marks, right? Quick wins. So equate the two graphs. Right? So the two graphs, remember the one graph, the original was the 2x plus 4, right? 2x plus 4. And then the new graph, which is our inverse, was half x minus 2. Okay, half x minus 2. Alright, and then you solve from there, right? So if I take the half over, I'm going to get 2x minus a half x is equal to minus 2 minus 4, right? 2 minus a half is 1.5, which is 3 over 2. Okay, and then minus 2 minus 4 is minus 6, right? And then from there, you're going to divide by 3 over 2 or 1.5 on both sides, right? And that should give you x equal to minus 6 divided by 1.5, which should be minus 4. Okay, you guys remember how to find the y value, or don't forget that you need to find the y value, right? So we substitute back into any of the equations. I'm going to use the easier one, which is 2x plus 4. Okay, I take my x value, which is minus 4. I substitute, right? This gives me minus 8, and minus 8 plus 4 is minus 4. Right, and so that is the point of intersection. The point of intersection is minus 4 and minus 4. Okay, and they want us to indicate this point on the diagram. Right, so let's go and indicate this point. You guys can see where the two graphs meet. Right, can you guys see that's minus 4 and minus 4. Right, so minus 4 and minus 4. Okay. All right, so a little bit of everything there. Very simple, nothing complicated. And that's how you do it, right? Okay, so just to conclude now, it should be clear that inverse of a one-to-one function is also a function. So if you find the inverse of any one-to-one function, it must also be a function. All right. However, in the next section, we're going to do many-to-one functions, right? The inverse of a many-to-one function is not a function. And I want you guys to ponder that a little bit, right? A many-to-one function is a parabola. So maybe try and go and sketch a inverse and see and tell me why you would say it's not a function. Okay. Now, this is going to be very, very important, right? Is that in order to make something that's not a function, we have to restrict the domain so that the original many-to-one function now becomes a one-to-one function. Okay, so then homework for today will be Mind Action Series, page 43, exercise 2, all. Okay, enjoy that and have a good day. Bye-bye.